Okay, welcome. So we have a pretty busy agenda, so let's kick it off for the next 2 hours. So welcome. You've ended up in the first meeting of the link switch vector routing working group. So I hope that was your...
Link state. Is it link switch?
Yeah, link state vector routing. It's on the screen. So, oops. So before we can actually kick this thing off, we need to have like 2 sets of direct contributors. One is a Jabber scribe, is somebody willing to watch the Jabber channel, make some notes from from time to time, and actually provide us some feedback if there would be like any questions for people who cannot be attending this particular meeting here. Please. It is a perfect opportunity now to actually look at the chairs and look at how great they're looking instead of at your screen. Any volunteers, please? Okay, thanks, John. So we also need to have somebody who's willing to actually take some minutes. Okay, Nabil, thank you so much. So the first, so now everybody can start looking up from their screen again, and smile instead of looking so mega busy. Now, before we kick this thing off, let us go through first, some set of administrivia. So the first thing we have is we have a note well. This is the new note well, as you can see. So give this thing a look, and it basically says like, whatever you say here is going to be in the public domain, and be aware of that. Also, we are distributing a set of blue sheets. Please fill this document in again. This will guarantee that the next time, that our area directors and the rest of the team will make sure we have such a comfortable room again for our Lsvr working group here. And also it avoids, people from the secretary making grumpy faces at us. That is always, very nice if people are smile and are happy. So this is the agenda, what we have intended here. So before we kick this off, so we're gonna, bootstrap it first with like a small welcome towards Lsvr. And then we're gonna, we have like 3 different topics we would like to discuss. First is the shortest path routing extension for BGP, so which is, targeting to be Lsvr specification. That's gonna be followed up with some applicability of that particular, technology itself. And then at the end, this is something which was introduced a little bit late as a draft, but we managed to, to push it through towards, the data tracker anyway. And as a result, we can actually also discuss it here, which would be some extensions for link state over Ethernet. And it would actually find its applicability area, particularly also in our working group here. And then at the end, we're going to define some next steps and on things and other things to do. So everybody happy with the agenda before we, kick it off? Any changes, modifications? Okay, cool. So, just a quick update on what the Lsvr charter is, actually about. And so in essence, Lsvr, the intent is for it to be a standalone protocol. So it's going to be like a hybrid routing protocol. And a question we get often is like, what does hybrid actually means? So it actually means that, we will be using a combination of path vector and link state technology, in those application areas where it is like most powerful. So on one end, we have the LSVs. These are the link state vectors. And these are just, data structures that are utilized to describe a particular device, and it actually will be used to calculate, calculate your routing tables and make routing decisions. Now, when each node in the data center is actually creating this link state vectors, it needs to be distributed, in an effective way, and that is where, path vector mechanisms actually are going to be utilized. So in the first phase of Lsvr, the plan is to actually use, as documented in the charter, to use like BGP-based distribution mechanisms. How it actually will work from a pragmatic perspective, that is what is going to be discussed, in the next few sections here. And then what you see at the bottom here is the initial focus is to actually really reuse what we actually already have with BGP. So BGP is a very nice way to transport in a loop-free fashion, in a way which is, well known by the operational community, and in a way which is like technologically, very, good in scaling and secure and so onwards. And it also, is very fine in managing different error handling mechanisms. So we plan to actually reuse, BGP from that perspective. So what is our focus of the working group here? Is it's threefold. On one end, it is actually to work upon the standardization of the protocol functionality. It is to document how a link state vector is, to what it is and how it looks like. And again, in the first phase, we're going to be reusing what already has been done from BGP perspective, like the BGP-LS. So the encoding and the packet formats will be reused from that angle. And then, in addition to that, it will also, document how the route selection actually is happening. So that means, we're going to be discussing the Dijkstra SPF-based algorithms based upon Lsvs and how BGP4 protocol mechanisms, the BGP-LS actually is encoded to transport everything here. Obviously, because at this point in time, it is very closely related with the IDR working group. So, any of the changes, so any modifications or extensions to BGP that are not really constrained towards, being used in Lsvr, should be still carried on, in the IDR working group. And it might actually, come to here if there is like, general consensus that actually is the right thing to do. So only time will tell, and the particular use case, on the particular topic is where it makes sense. So that together, between all the chairs and the area directors. So from the initial charter, we have like a few milestones and a few documents to deliver. So we actually are chartered to deliver the following documents. So the first one is a specification describing, what is an LSV, together with Dijkstra SPF root path calculation, and utilizing, the existing BGP protocol baseline functionality and the BGP-LS packet encoding. In addition to that, we also will document some of the protocol extensions required to, efficiently, reuse BGP to facilitate that, to distribute the LSVs within an IPv4, IPv6, data center. And we will also look into a lot of the privacy and in the security considerations. So what you can see here is I put like, a square around this is because, it's not because this can be different documents, this can be actually in a single document. I think it makes sense to actually, have them into a single document, but I'll leave it up to the working group on what we actually find, what is best, going forward. In addition to that, another piece of information, a document we need to create as a working group is the applicability statement. So, we know what Lsvr is, but it is actually important to document how to use it correctly and which are, different ways of how to deploy LSVR as a technology, in the best possible way. How will it, for example, interact with other routing protocols? Is maybe LSVR running on top of, the same session as BGP and so on, right? So these are things which will be covered, in that particular document. And then, of course, this technology needs to be, managed also. So we need to document. We need to look also into, into the young models, specifications for LSVR. So from a milestones perspective, so we have been given a very ambitious goal. So the plan is to actually have something ready by, March next year. That is very ambitious. We have a lot of work ahead of us. Going to the direction. Now, that being said, there is already quite some good documentation actually out there, which seems to be putting a very good, stick into the ground to actually start working from. So in July 2019, so the middle of next year, the plan is to actually have a young specification ready also for the LSVR spec. So as mentioned, so we have a very ambitious goal, and as we all know, people tend to do a lot of work just before the IETF meetings itself. So that actually means, we're only going to get 6 weeks of fine, good work. People normally, if you don't do anything special, if you just go towards the IETF meetings. So it was actually our plan to do an interim meeting in between each of the IETF meetings to keep, the process, and the development of the technology, going forward, basically. So the interims will actually happen somewhere in the middle between each of the IETF meetings. How we will actually, do that, that is something we still need to. So we're looking into both either a face-to-face meeting or into WebEx, online meetings. It will probably be online gatherings, but we'll need to see that together with the other directors and how they actually, think is the best way for driving this forward. So we're going to have some really good, process time ahead of us. So that was a quick, intro on where we are from the LSVR charter perspective. If no further, questions or anything else, then I would like to give it to the first speaker of the day, Keir. So we have a pink square for you.
Super. Cool. Ready?
Yep.
Perfect. So, good afternoon, folks. My name is Keir Patel, and I'm going to talk about the BGP-based SPF extensions. This is the draft I've co-authored with AC, Abhay, and Venu from Cisco, Wim from Nokia, Sean from LinkedIn, and Derek from Arcus. So, we know massively scaled data centers have implemented some form of simplified layer 3 routing for the class. For a centralized route control, they use a controller-based solution. And from an operational simplicity, a lot of these MSDCs have actually converged on BGP as their routing protocol for their layer 3 routing. Now, the route controllers in itself has similar functionality to route reflectors in sense that they may reflect routes, or they may act as a central database for policy enforcement, any kind of route management, etc. However, traditional route reflectors that are or not in forwarding path assumes a presence of an underlay, some form of an IGP that help resolve next stops and its adjacencies. For BGP-based MSDCs, they have solved these problems typically by using hop-by-hop in-band peering sessions. So the proposed solution here is one where we want to facilitate deployments of route reflectors or route controllers that may be in-band or may not be in-band, and yet achieve the operational simplicity that is given to us by BGP. So here are advantages of using SPF in general as opposed to a distance vector algorithm. With BGP SPF-like solutions, the node will have a complete view of topologies. This is pretty ideal when you start to use BGP or any protocol as an underlay protocol. Only network failures need to be advertised as opposed to all routes, and this would result into a faster convergence or better scaling. And lastly, SPF in general lends itself to an optimal path selection in any peering models, be it a route reflector or a controller-based topologies. Here are the advantages of using BGP. It's already been deployed in a lot of MSDCs. Fairly robust and scalable implementations from different vendors do exist. It has a wide acceptance and therefore has a minimal learning curve when you start to play around with BGP. It runs on TCP, therefore has a reliable transport and guaranteed in-order delivery of data. Supports incremental updates in any and every mode. Avoids flooding, and you could do policy-based routing. And lastly, it really lends itself fairly easily to multiple peering models, including reflectors and/or controllers. So then, here are the changes that we would probably need to make to BGP to achieve this functionality. We've defined a new SAFI and therefore a new NLRI to support this SAFI. The format of the NLRI is exactly same as the format of BGP-LS that is used to carry link state information. We've defined a new capability and a node attribute that will assure compatibility between two BGP speakers that are deploying these extensions. Supports multiple peering models, and lastly, replace BGP best path decision process with Dijkstra. So in a typical BGP AFI-SAFI announcements, you have routes and you have next stops. The next stops in itself are resolved by a presence of an underlay protocol. In case of BGP SPF, since the best path is replaced by Dijkstra, the Dijkstra will end up computing the next stops. Therefore, any next stops that are received along with the NLRIs are usually ignored upon the receipt. The next stops are needed to be announced so that the compatibility with 4271 RFC, the base BGP RFC, remains. Then the decision process phase 1 and phase 2 are replaced by SPF algorithm. And finally, the decision process phase 3 may be short-circuited since NLRI in here is unique per each node. Lastly, we need to ensure that most recent version of an NLRI is always announced, and we use sequence numbers to ensure this is the case. From an SPF standpoint, we have started with a greatly simplified SPF that supports point-to-point links within a single area.
AC Lindem, Cisco. I just wanted to point out that this sequence number is similar to what's used in EVPN for MAC move detection. And so it's not really a new concept.
Cool, thanks. Greatly simplified SPF is used, again, for point-to-point links, and the scope is constrained to a single area. Can support the computations of LFA, segment routing SIDs, and any other IGP features, as LS has mechanisms to announce this within itself, so it could be naturally extended. The current version of the draft only focuses on the simplified SPF. The link state AF that we support in the draft is a dual stack AF, which means it supports both V6 and V4 addresses together. Support for VPN SAFIs are kept out of the scope for now, and there is some work needed to define the interaction with existing unicast AFs that are present in BGP. We think this is a matter of local implementation policy, and the draft does make a recommendation as to what should be done, and we'll be talking about it in the later slide. From convergence standpoint, no new changes are needed to be standardized. However, the draft does make recommendations for implementations to follow if they would like to achieve a better convergence. One of the recommendations is that any local changes to the node or a speaker should be announced ahead of the changes that are otherwise pending. So for example, in case of session outages, you typically withdraw all the routes that you have received from your fellow BGP neighbors, but it'd be great to announce the link state information ahead of all the remaining routes so as to facilitate the faster convergence. There's also investigation and some work that has been done, particularly to see if we can find ways to dampen the announcement of all the routes that are present in your edge rib in for the speaker where the connection has gone down using the variation of graceful restart. This would make BGP a lot more closer to any IGPs. And this is an initial investigation that's been done. We're not sure if we need these changes. It may not be required. Simply reprioritizing of how you announce your updates may be good enough. But then again, this is the work that has been looked upon and investigated. From an AFI-SAFI interaction standpoint, BGP SPF today has a support for V4 and V6 unicast SAFIs. The legacy BGP also has the support for the same SAFIs. There is no implicit route leaking that needs to be done between these SAFIs. Whether you leak or not is a matter of local implementation. From a policy standpoint, it would be a redistribution policy that you would have to implement or enable. And draft does make a recommendation at pretty high level to say that the admin distance that is used for BGP SPF should be set in such a way that it prefers the routes over legacy BGP. The draft will also make the similar recommendations in next revision for IGP protocols also. And lastly, the peering models. As stated, BGP sessions will support all kinds of peering models, be it with route reflector or controller in band or out of band or a direct peering connections. Any link level discovery or liveness detection has to be done outside the scope of the work that has been presented here. If the route reflectors and controllers are present in a way that they are not directly connected to its clients, then they would need to resolve over some routing so that the connections can get established. And this connectivity dependence should not be there on the SPF SAFI in general. Furthermore, the controllers could learn expected topology information also through some other means other than the protocols. Classically, this would be through some configuration, and the BGP SPF SAFI should be able to consume this seamlessly. The peering model is discussed at length in an applicability draft that AC is going to cover in the next presentation. So that's about it from my end. Questions?
So actually, who in the room managed to read this particular draft? Okay, about like 15 to 20 people. Okay. So anybody, any comments or any feedback on some of the, decisions which were made, in that particular document? Nobody. Okay, interesting. So, okay. So one of the things which is mentioned in the chart here also, is that, the document what is created here really goes from an extension towards BGP, correct?
Indeed.
Yeah. So if you would do like a search through the document about Lsvr, it only pops up at the header somewhere. So is there like any plans to actually, carve it up into into the documentation sections as mentioned in the chart itself, meaning like in documentation, specification of the LSVs, and then, carve up another section, like the distribution of the LSVs, through the network. Then a third one, calculating the SPF based upon the information available in the LSVs and so on, right? So right now the document is like not structured like that. So what are your plans around that?
That's a good feedback. We can incorporate it in next rep, for sure.
AC Lindem, I'd like to point out that Gunter is making this comment after no longer being an author of the document.
Randy Bush, if it's so complex that it needs to be split into multiple RFCs, then there's a problem.
So another element, which was in the text was discussions about like, the normal SPF and strict SPF. Can you explain a bit more about that? Or?
I'll let AC handle that.
AC Lindem, Cisco Systems. This is, we are using the same IANA registry that the IGPs are for algorithms. Now, the difference between the normal SPF and the strict SPF is that the normal SPF can be overwritten by local policy, whereas the strict SPF must take the shortest path. And this, I mean, this was discussed ad nauseum in the ISIS working group, but we're kind of inheriting this level of complexity, this distinction between normal and strict SPF.
So question for you, Keyor. So where do you think actually you need, some support from the working group to progress, this work further than where it is right now? So what sort of input are you looking for?
We'd be looking for input to say whether, the solution that's presented is there a refinements needed? Any good deployment use cases? If there are operators in the room, they would look at it and say, this is something that is worth deploying or could be deployed. And finally, folks from implementation side of the world to implement, prototype, and do some interoperability testing.
AC Lindem, obviously the most valuable would be any prototyping and implementation. That's what I would say. We're hoping, yeah. And it's all of us have lots of jobs, and right now I'm not involved with implementing this, but I really think it's I'm not sure if this is the answer for data centers, but I think it's a very promising one. Otherwise, I wouldn't be spending the time on the standardization and all the investigation of it. But implementation would be key.
Okay, thank you. So can you actually create like a list of items where you think the draft actually needs additional feedback?
Sure, we can do that. And maybe from our perspective, I can make one quick comment, is that if we can issue a call, at least for an adoption on a mailing list, maybe that will get some discussions going. And in parallel, we'll get the list of comments prepared up ahead of time. So we could have some discussion over it.
I haven't talked to that many providers, but the ones I have talked to, I believe that this is going to happen whether the IETF does it or not. And I think it would be better for the industry if the IETF did it.
Okay. Now, actually, I do have one other question also to the working group here. It's from the people, who have read it, and also the people who will actually read it, coming out of this working group and thinking it's the most dazzling idea you ever see, laid your eyes upon in the last, 3-4 years. So are there like any people willing to, to actually give feedback about this draft in the next 2 weeks? So if Alvaro. Yeah.
Hi, Alvaro Retana, Routing AD. So I'm really happy to see all of you here today. I'm very happy that you all came. I'm very disappointed that no one has any questions. I know Keir for a long time. I know he does good work, but it's not perfect work. So I hope that you read this, because even if, as George says, this is going to happen, we want it to happen right. And we want it to be well specified and something that people can implement and something that people actually read and had some comments on. So this experiment or this exercise of doing this working group is not so we can rubber stamp what Keir already did. And maybe I'm wrong, maybe the document is perfect. But please, if you think it's perfect already, at least come up and say that you have absolutely no concerns and no comments, and that it's absolutely perfect. And we can go from there. So this is a working group, right? It's not, it's something that we expect people to participate in and work as a group. The same not just for this document, for the other documents, and I hope that the plan that Gunther and Victor put out there of having not just meetings at the IETF, but interim meetings to accelerate this work, that it works, and it is not a one-way communication. That we have, discussion and comments and other things. That's it. Thank you.
Yeah. So what I'll do is I'll actually submit a working group adoption call, and I will be looking for feedback, positive and negative. So if you have only negative things to say, please speak up. If you only have positive things to say, please speak up. But please do not be silent, because silence doesn't help us at all. We need to have feedback. We want to move this thing, forward in the best possible way. And, even though if your document is perfect, good, but let us know. We just don't know right now. So, okay. Thank you.
Thank you.
You have a bit more than 20 minutes.
Oh, man. Oh, I can see it right here. That's good. So I'm not going to make any pretenses here that this document is perfect, because we put this applicability together rather hastily after the working group formed. And and most of the thinking that's been done has been done in the last couple weeks and on the applicability. And the slides actually include a lot more than in the base document. So I would ask you not to read the document right now and review it. I saw Victor ask for people to review it, but the next revision. Okay? Is that fair?
When is the next revision coming out then?
Is that a trick question?
No, it's a question. It's not a hypothetical question.
How about before the anniversary of Abraham Lincoln's assassination?
Was that in real time?
April 14th.
Okay.
Okay. I'm going to talk about applicability and different peering models, security, and then I know this isn't supposed to be a sales pitch, but I'll have to finish with that. I believe Keir talked to some of these things, but as a lot of you know, we're already using BGP as an underlay in a lot of data centers, and a lot of these are massively scaled data centers. And as Peter's draft and routing working group 7938, it just uses base hop by hop BGP, and this would be a direct replacement to that. Additionally, this kind of fits, and we'll go more into this, into the central controller model, because we're also already using central controllers, and the main mechanism for providing topology information to these controllers is BGP-LS today. Again, we can look at this from a route as opposed to a route reflector topology. And I'm going to talk more about this as well. But the peering model in 7938 doesn't really lend itself to route reflectors. It's just a very simple hop-by-hop exchange of BGP NRLI. I really want to get to the beef of this. Okay. I just want to point out, and I don't want to, a lot of times when you put up these slides, people that are really experts in the topologies will point out that this isn't true. It'll support either fat tree or clause. I know in the chart of the working group is data center, LSVR for data center. But I'd also like to point out that BGP SPF could be used in other areas. It's just, I mean, other topologies and be applicable to, you know, provider backbones or other things as well. But since that's not the scope of the working group, I'm not going to talk about that today. Here's the 7938. Now, the interesting thing from this is a three-tiered clause that's taken directly from 7938, as the other two pictures you saw were stolen as well. But you would have a BGP session on the local address of all of these links between all the switches, you know, whether it be in the leaf or the aggregation or the spine or layer. So they called it in the topology. This would be a five-stage topology as per the terminology in 7938. And I think I talked to this. As far as applicability, we're not looking at, you know, VPNs or anything like that. You would use normal BGP for the overlays, all the address families other than the base unicast, IPv6 and IPv4. Especially for this first, you know, these documents that we're trying to do very quickly in a year. We wouldn't even consider using it for, say, VPN, you know, IPv4 VPN address family. We're recommending BFD for faster link detection of the downs as opposed to aggressive hello and hold timers. Now, I'm going to talk more about this, but one of the drawbacks that people have pointed out, I believe Jeff Haas was the first one to point this out, was that if you have a node failure and that's your best path, you need to withdraw, discard all the NRI from a peer. So clause topologies, you know, a lot of these we've seen in data centers up to 64-way ECMP from the leaf to spine layer. Now, granted, if you have a copy of the BRIB for each of those in the leaf and it goes away, that could be a lot. Now, because of this, for applicability, you don't want to use AdPath. AdPath is absolutely it's bad in this because you really only, you just want to make sure that everybody has a copy of the NRLI. And since NRLIs are unique, and if you're very familiar with RFC 7752, you know that the NRLI is defined by the node by the descriptors. You know, node descriptors, link descriptors, and prefix descriptors, depending on what type of BGP-LS NRLI you're having. So really, the only version of the NRLI interested is the one that's originated, and you only need one copy of that. So AdPath is actually something you don't want in this type of, for BGP SPF. Now, I'm also thinking what you do is you could also do sparse peering. In other words, in some of these more dense topologies, these dense class topologies, you wouldn't run a BGP session on every link. Rather, you would use BFD or something else. Randy's going to talk about a different proposal, but you'd use you'd do the liveliness detection outside of BGP, and then depending on that, you would advertise NRLI corresponding to those links. So, for instance, you could say, okay, the leaves are only going to talk. You're only going to have BGP sessions, even though they're going to advertise every single one of their links in their NLI. They're only going to They're only going to have sessions with 2 spines, even if they have 64 way ECMP. It's a trade-off. And if 2 isn't enough, maybe you do 3. But you certainly don't need 64 upstream BGP sessions and 64 copies of the same NRLI in your BRIB. I mean BGP RIB, for those of you unfamiliar. And then the spines could, with controllers, and you could go to any level of data center hierarchy. Here's the direct model. The direct model I didn't. Here's the sparse peering model. For instance, here, you see those red lines are the peers. You see here's just an example. You see that although the leaves have 4 upstream links to the spines, they are only peering with 2. And you'll also see that you have a left spine and a right spine, and those left spine and right spines, they only have they only leak their routes to one side, to one side or the other. And so then the controller gets a consolidated view because he's getting redundant copies anyway. He's getting at least 2. Now, there was one other thing I wanted to point out here. Oh, I wanted to point out that the controllers reflectively only, you could also cut down on the amount of topology information disseminated by using a policy to determine, say, that the left spine only reflects the routes from the left side and the right spine only, the controller on the right only reflects the NRLI from the right side, further mitigating the effects of having a copy of the BRIB for each best path upstream. Here's a third alternative. Again, you'd use BFT to determine your liveliness, so you wouldn't need all the sessions, and you could remove the hierarchical route reflection. But you'd need some other way to make sure you had routes for those BGP sessions and determine the right paths. And I'll just give you a picture and you can see this. So in this case, the only BGP sessions for this BGP SPF are with the 2 controllers. And there is a session, that both controllers, or you could have 3 controllers. Now, the only complexity is that you, and you see the red and green for the 2 controllers, different sessions. I had to point that out because I upgraded to High Sierra. I had to pay $100 to get my omnigraphel to work again once I did that. Anyway, This one, in this situation, you notice that the leaves don't have a direct route to peer with the controllers. So you would have to do that out of band. And I think the proposal Randy with the discovery mechanism Randy's going to talk about after this is one way to do this. Yeah, so again, the whole thing about this is you would only use this for the underlay right now. That's the only applicability we're looking at, and you would still be using BGP for your VPNs and your other address families. And you're also the controller is already getting BGP-LS, and one side benefit of this is the distribution of the BGP-LS could be used for other applications. For example, BGPR SRTE uses the same BGP-LS or the same or more of the BGP-LS for computing the traffic engineered paths through the data center fabric. So this wouldn't be a viable internet draft if we didn't, this isn't in there yet, but this is just some thinking that I did in the last week for this. This really isn't much different than RFC 7938, the hop by hop BGP peering. The only thing that it's different is, we probably, since it is a new proposal, and the 7938, this is standard track, and 7938 was just informational. We really want to suggest some good security. And what I do is I'd mandate the use of TTL security for a BGP session. BGP sessions within the fabric. That's the first thing. And with that, you really get a lot of protection. You really, because you get a protection on all your inter-switch links in the data center. And really, it's only, the VMs and, the northbound and the VMs and servers that you have to worry about. And if you're doing, so the fabric should be isolated. So if you think you have problems with vulnerability from like say the servers to the leaves, you could also use RFC 6192, which are recommendations. And by the way, most data center switch vendors do have something, do have some firewall rules to protect the control plane anyway. I mean, some that come pre-configured, at least some of the ones that I'm familiar with. These are recommendations for firewall, for what you do on interfaces to protect the control plane. I don't know, it's a good RFC if you haven't read that one yet. I'd also say that, I'd recommend that. Now, I don't know why, but if you had a data center where somebody could get in and get around the TTL security and subvert the fabric, which I don't think a lot of people worry about, but there could be some data centers where, I don't know, maybe if they're physically, geographically disconnected and go over the public internet or something. I don't know how this, but in that case, then you could use TCP/AO. I think more about the trust, the models. TCP/AO, and the keys should be periodically rolled over using the key chain, using the Yang model in 8177. So, and you should change the keys periodically, or anytime there's a possibility, like you have an employment change or something, that, there could be a breach. I just wanted to point out one more thing. You see in this clause, this is the picture I'm talking about, where you see that the leaf could have, for all 4 of those spines, they'd have a separate copy of the NRLI. And we wanted to determine whether that is a big problem or not. I think initially we're not going to do a lot to make this more like the IGPs, because we could go, off the deep end and start changing it to make it more like adding things like aging and mechanisms to make sure stale NRLI get deleted, just like IGPs have, and go off. But I think once you do that, you're kind of losing a lot of the synergies you have. And those would be things that wouldn't be, if somebody wanted to do that, or if we find we need that in some scenarios, then we could do that in, future work, as opposed to holding up the base documents with radical changes to BGP. Not to say that replacing the decision process with a different determination of whether or not that's what we're doing already, just determining whether the NRLI is unique, has been changed, and goes to the top before any best path is done, and then replacing the whole SPF. That's already a fairly fundamental change, but it's fairly well understood. Whereas we start going into ideas of determining when to send data, that's going one step further, and we're going to try and stay away from those, at least for the first this first version of documents we're trying to get out by March of next year. And here again, so you have BGP for your underlay, you have BGP for all your overlay services, and you have the synergy of the same BGPLS. That's, even though we're using a separate address family, that doesn't mean the controller can't avail it for calculating the SR, and not just SRTE, but any TE paths. I can tell Tony's enthused. And here we go. Another omnigraphal picture. This one's my own, not stolen from the internet. You can see using BGP, not just for breakfast anymore. And that's all. So yeah, like I said before, don't review the current version of the document. Wait for the one with the more tofu.
Yes.
Jeff, I was waiting for your presentation to make this comment, to see if it was addressed here. One of the things the chair's brought up is you need a Yang module at some point. One of these 2 sets of documents needs to talk about how this is going to interact with the existing BGP Yang module, because you are still going to need a provisioning layer, which partially lives in there. Your configuration and operational state are significantly different, so there's going to be a lot of weird interactions.
Oh, right. Yeah, that's a very good point. Yeah.
Jan Fedurin, Bloomberg LP. So on the applicability statement, I mean, it's great that you guys have developed yet another protocol to help, massively scale data centers. Yeah, that's amazing. But I think where, the only place where I see this in any way like applicable is if I'm going to start building my data center or, special, exchange topologies that are going to be based, that are not going to be pure clause, or that are not going to be pure fat trees, or that are not going to be, very clear, core distribution access, or whatever else, is being called these days. Other than that, I'm not sure I see too much value in having this be, adopted.
Why, the first statement, why do you see it only, I'm not saying, that if it's not Claas or not fat tree, why are you saying that problem is solved or?
Oh, no. The problem is, I mean, this can be adapted absolutely for Claas, for fat tree. This could be adapted for anything. I'm just saying that the value that, I mean, if you're going to talk about it, the primary, applicability is if you're going to be building what I would call irregular topologies, and you need to support T in those topologies, and you need to do all kinds of optimizations. Then I think this is what probably this should be, aiming for.
Okay. I guess I don't see why that would imply that there's no need for an underlay in regular Claas or T's or fat tree. What are you using for an underlay? Are you using Rift then?
Do you mind speaking in the mic?
Mike, yeah.
Yeah. I mean, because you said you'd use it for different topologies. But you didn't
The
say why you
solutions,
don't need-
the solutions for
need it.
standard Claas and fat tree have been developed.
Okay, that's
That's where I'm going with that.
okay. Okay.
So AC, can I ask a couple questions then? So just for clarification, so we got it right. Basically, what you had put in the draft was the apparent initial considerations would be Claas or fat trees that could easily be used in those environments. But you were stressing that those are not necessarily limiting where this could be used, correct?
Well, one thing we've been saying about this, which is really nice for BGP SPF, is you could take all this innovation we've been doing over decades in IGPs, for example, LFA and all the different flavors of LFA. However, in a Claas environment, in a Claas topology, LFA doesn't really buy you a lot. I mean, you can get, if you have fast rehashing of your next hops on failure, because you have this dense ECMP, you don't need LFA. You don't need all these flavors. You're not going to have it. You don't have looping topologies, right? You don't need, you just if you rehash your next hops based on failures really quickly and do it well in a pure fat tree, or you're going to get everything you need.
And one more question. And then the other discussion point, you had mentioned.
Well, I was just going to say, but you could use BGP SPF in different topologies. And I know this is only data center, but like say outside of this working group, you wanted to have a pure BGP that had a BGP overlay, and you wanted to use BGP on a ring, like a metro ring. You could do LFA with that.
Yeah, no, makes sense.
Okay.
And so second quick question, you had mentioned some efficiencies, obviously, that were recommended or potentially recommended for a sparse mode operation. Now, are those necessary in your mind, or that's more like an operational benefit
for the second option, where you peer with a BGP neighbor that's more than one hop away, of course you need some way to get to him. Anytime you take it beyond one hop, you need something else. But for the first sparse one, where you only peer with a subset of your directly attached neighbors, no, you don't need anything for that. Okay.
Yeah, one more question, actually.
Oh.
Yeah, just about your ideas about how this thing. So can you go back a few slides? I can do it myself, actually. I have the power. So if you look at this particular deck, you can see like lots of stuff traveling over, potentially the same BGP session. So I think it's also touched upon what Jeff actually was kind of mentioning earlier, is how do we see this thing going forward? Will everything, still travel on the same session, including LSVR? Or do we want to go as strict going forward to say, okay, if you do LSVR, everything else is excluded from the same session, because that would potentially avoid people by shooting them in the foot by using this and get confused. So how do we see this thing going forward?
So, Keyur Patel, today BGP provides means to set up multiple sessions. You could set up multiple sessions and separate them out. You could have a single session, and as this is a different SAFI, you could carry it completely on a different SAFI, right? So there is no interdependency between that. It seems like that would be a operator's call as to how he would want to configure these sessions and how he would want to operate this within his or her network.
But you have. So you're not looking. Yes, Jeff. Go on. Sorry.
Sorry, Jeff Oz. So Keyur, if this was normal routing, I'd say I agree with you. This stuff is latency sensitive. You probably don't want to have the stuff stovepipe, caught behind the queue of other things that may have a lot more messages. This is, in spite of the fact that I believe in prioritization, I think this is something I would recommend you all strongly advocate for separation of sessions.
Keyur Patel again, I'm perfectly fine with that.
Yeah, I think that's something that's missing from my slides, and that, which will go into the applicability. But I think you definitely want, the same way that we recommended that you give the routing preference or administrative distance, you give the BGP SPF, since it's the underlay precedence, you'd want to say for processing and queue handling and update generation and everything, yeah, which should be given preference. You get that should go in the applicability.
Alberto Tana, routing AD. So strongly advocating is great. That doesn't mean, that's not the same as mandating that, right? So in other words, I think Jeff's comment still applies. We need to make sure that we write down all the potential considerations, whatever, right?
Let's start a thread and a list on this one. I think this is a key point, whether we want to mandate it or recommend it. IDR chair.
John Scudder, Juniper Networks.
Oh.
I also am the IDR chair, but I'm not speaking as such.
Okay.
Yeah, I guess I just want to sort of underline what the last couple people said, which is it's kind of ironic to have a slide that says operational simplicity up at the front of the room while KR is in the back of the room saying, yeah, we can do it this way, we can do it that way, and we're just going to hand a whole bunch of knobs to the operators and tell them to figure it out. Yeah.
Okay, comment, hat off, so down at the mic here. Victor Coursing, still dying. I guess my thoughts are, this is more of a perspective. I did hear the comment recently that, kind of there's a problem solved scenario. I mean, from my operational background, building networks for about 20 years, I never thought any problem was ever fully solved. I thought we were getting better at solving problems. The types of networks we built and the reason why we're building them and the thought that goes into what we need to support has changed, at least from what I can see from the 90s till now. So I've always thought that having a few options have been beneficial. We've exercised a lot of those options over time. There's not a network we have built from scratch that really looked like the previous network foundation. There's always been deltas. And those were being driven because the requirements have changed drastically. When I think about what's going into building larger infrastructure, people call it cloud, but there's things there, right? Large data centers, they scale very differently. Those didn't exist 10 years ago, or maybe they did 10 years ago, but 20 years ago, we weren't talking about that. We're building networks now that look very different. We're gluing them together very different. So from the operational side, I've always found it beneficial to have options. Options where we can actually choose to build something the way we need to build it. And, even if I go back to the LSVs, like look at ISS versus OSPF, I mean, use them both. Sometimes one was better than the other. I would not know what life would have been had I not had that choice. So from an operational standpoint, I feel that choice. And just to comment on this last one on simplicity, I mean, yeah, I like options as an operator to do it one or the other way. recommendation is always good. I like options. So that's my comment.
Jeff, so prioritization, maybe look back in the draft for a point we had talked about in the prior session, which was TCP interactions. So again, for normal BGP, you can live with things stretching out a little bit based on TCP timers because you deal with lost packets, that sort of thing. Again, with things that are link state-ish, do you care about latency a lot more? You start running into TCP backoff issues, then this potentially interacts with the latency requirements to get this data across the BGP session. So that should be something that's dealt with in your document as well.
The base protocol or the applicability probably, right?
Very likely the base protocol. But
Base protocol.
Applicability is where you seem to be wanting to discuss the hows of rather than what to do.
Now, I haven't seen this, but I've heard people that talk about, this isn't BGP processing, but I've heard people talk about route reflector implementations and how, full BGP tables are sent in, like 1.5 seconds or less or something, so I'm not sure. This is something I think we need to discuss too, whether with TCP you really have problems with backoff and whatnot.
Again, it's
In 2018, yeah.
absolutely in 2018.
Okay.
It doesn't matter under stack.
Yeah.
The point I guess I'll make is that you won't find people that haven't done BGP implementations as an implementation or developer or somebody who's actually troubleshooting stuff that don't end up effectively being some level of TCP expert, even at a low level.
Yes.
Because it makes your life miserable.
Yeah.
Yes.
Maybe I'll sit down for general discussion then. Okay.
Okay, cool.
Yeah.
Thanks. How long? As much as you want, as much as you need.
Hi. Well, I don't know what time it is. Hi, Randy Bush. I have 2 lives, well, 3 lives, but you don't care about the third. One is I work with Kayer at Arcus, and the other is I work at Japan's oldest commercial ISP. How many people here actually within the last year operate a medium or large data center? Okay, a couple. Yeah, we're building our second 6,000 tour data center, and we consider it a medium-sized one. Okay, so, this is the wrong one. So let me go quickly. This is done in a white room. There's no IPR, and it's completely white room. What that means is I didn't look at, for instance, the details of LLDP. That has its benefits and its failures. Okay, so LLDP has IPR issues is part of the reason why. Okay, let's see if we can do it. Okay, I can just spin it straight, pull up anything.
Can you use the older one or not?
Either one. A couple comments on AC's thing. We have a long history on the internet of things designed for the LAN end up on the WAN. When you're talking about BGP security, one-hop TTL, just don't cut it. Okay? And this, what I'm going to present, one of the big gaps is security. One of the reasons I'm pushing this instead of LLDP is because I believe we need security for link state and, no, this, okay, fine. And LLDP has an artificial limit of 1,500 bytes. And I like to carry big fat security globs around. So anyway, motivation here is no central controller. That's not really true. I have a friend who works for a small ad company who says they like to run their class hot and they want to micromanage flows. So this is essentially a link discovery protocol that can push up to BGP SPF, which I'm going to use as all the examples because that's my admission to this show, but it could be used with central controllers, et cetera. So BGP SPF needs neighbor discovery, liveness, to heck with BFD. It needs hot liveness, okay? LLDP is hard to extend. We wanted something simple. So think of a new ether type with TLVs, okay? The basic thing is, tough luck. Sorry about this meat echo, but I want to point. Is you've got an east-west protocol at the ether level, okay? MAC link state is exchanged and pushed up the stack northbound. The AFI-SAFI information is gathered over the ether to ether protocol, and then SPF or whatever your controller is operates at a higher level. Okay, so the east-west protocol, and I'm going to skip the packet porn. This is full of packet porn, but let's just pay attention to the core of it. The ether protocols, PDU sequences with checksums, all the normal garbage. PDUs, one or more Ethernet frames. You can reassemble them if you need to. And payloads are assumed to be IP over the same Ethernet. In other words, hey, I'm going to be competing with payload traffic. So we have to think about failure and congestion. Okay, there's a basic PDU. It has flags. It has a checksum, okay, because we don't trust the hardware. And there are two basic types, which is hello, keep alive, capability, exchange. Okay, checksum, blah, blah, blah. What essentially happens is it wakes up and we both say hello to each other. If I can figure out how to operate this. Okay, so that allows me to discover your MAC because you shout, I shout, we find out each other's MAC. For this, I consider the ASN the identifier because we're doing this for SPF, okay? We negotiate timers if we want to change them. Otherwise, keep alives, I forget what the standards are. I'll get to that, what the default is. Then we can negotiate between us what AFI-SAFIs are supported using capability exchange. Hey, I support V6. Hey, I support V4. Hey, I support MPLS V6, et cetera. I announce my layer 3, layer 2.5, or layer 3 NLRIs or 6s, MPLS labels, et cetera. We now have full reachability information, which we can push northbound. Okay, here's a keep alive, blah, blah. Once we know the max, we can start running hot keep alives very frequently. Okay, negotiate capabilities, negotiate timers. Okay, now we know the max and the ASNs. Now we can start talking about AFI-SAFIs. This, as it's defined so far, supports V4, V6, MPLS. You could do other tunnels. Okay. So now we can exchange our interface AFI-SAFI stuff, okay, for the ones we have negotiated. So I can say, here's my list, and this is my primary address, okay? It's over an unreliable transport. So again, there's sequence numbers. The sequence numbers are ACT, all that kind of stuff. You'll enjoy reading the draft. You don't want me to drag you through this packet porn. Okay, there's an ACT. Here, for instance, an IPv4 announcement, which has, as I said, sequence number and all that stuff. The count of V4 addresses we're going to have here. Are you adding it, dropping it, and who's the primary? So for instance, if an address change or a MAC changes, that change is immediately noticed. You generate an add and a drop, and it's pushed up the stack. Okay? Same 6, same MPLS, etc. Okay? If you have one label associated with multiple AFI-SAFIs, use multiple label PDUs with the same label. Okay, so now you can test IP level, or layer 2.5 if you insist, liveness if you want. So now you can start talking about BFD, etc., if you're not satisfied with the ether level liveness being pushed up. Okay? So now we know our interfaces, we know our AFI-SAFIs, we made friends with our neighbors. We want to push it northbound. Okay? So we now use what we call the north-south protocol to take it. It's going to stop right here because I don't want to get into the 7752 formatting because you may choose something else. Okay? We assume for north-south we have a reliable transport. We assume a nice fat PDU. Okay? The northern half signals to the bottom half, hey, I'm ready, let's rock and roll. Okay? And it can restart at any time. The ether layer sends the full topology north and incremental updates as they occur. Hey, my neighbor's MAC has changed. Hey, we've got new IP addresses, etc. Okay, so there's packet porn about all that stuff. Okay, nothing very exciting. AFI-SAFI types, etc. The shim takes the above and translates it into LS PDUs. Okay, 7752. Okay. The topology layer, like SPF, can now construct the full link state and IP and MPLS topology. BGP SPF can run. That's all you need. That's a Britishism, sorry. So the point was a very simple link layer, liveness, etc. The reason is, essentially for all this, is unfortunately, Tony hasn't finished his work and the IGP doesn't scale yet. Right? I can't run a 6,000 Tor data center on ISIS, and I'm an ISIS freak. Right? Questions? Answers? Hey, AC.
AC Linda, Cisco Systems. Now, I think what we got to decide here is, do we want something that's going to work better that is applicable to our scenario? And that's it, because
better is a comparative.
Well, this will definitely work better than, say, LLDP, because we're doing it here. We're doing it specifically for this task, right? For this, or do we want to, try and write on those? I mean, I'm supportive of this work, but I know that that's the big question we're going to, we're going to have to ask ourselves. Because this, I mean, for BGP, this is really, this is doing something that's customized. Just like the home net, we can do our own better than, right?
This
than other-
isn't custom for BGP, as I said at the beginning.
Okay.
You can use any form of controller protocol you want northbound. I
Right,
stopped at the
right.
7752
okay.
shim for a reason.
Okay, okay.
You can push whatever you want up there.
Yeah, uh-huh.
My ticket to admission to this party was that it works with SPF.
Right, right.
And when I actually looked and said, where does this work go in the IETF?
I think, yeah.
There's no place really. We don't do this level work anymore anywhere.
And we have the first level requirement. So we could probably, I mean, there's proprietary solutions to this, and this would be a standard one, and we would do it.
No IPR.
Yes, great.
Jeff,
Jeff Haas, Randy. So the
who
question
are you, Jeff?
I said I was Jeff Haas. I'm sorry, you can't hear me. Please turn up the hearing aids. So my question to you is, we obviously need this or something like it. This has very strong overlap with the hello portions of 2 IGPs. Does it make more sense to strip off those pieces from one of our existing protocols and allow us to run basically a shortcut IGP just for discovery?
That's a pass.
Atlas, just on the where to discuss it, please do remember that RTGWG exists as well for talking about routing related stuff that doesn't have a better home. If this fits perfectly in Lsvr, that's great. But if you think it has wider applicability, which you seem to be saying, RTGWG would be a fine place to have it talked about as well.
Okay, so you have anything else would like to add? Okay.
No.
So from what I'm hearing actually is that from, a link discovery, kind of mechanism, there are like a few ways to skin the cat. Yeah? So this is actually a solution for doing that without IPR.
A very thin, I hope it's simple, and I hope it can stay simple. But I note that there are some problems. If you're not using it, for instance, with BGP, the fact that the identity being pushed northbound is the ASN, and you're going to want to use a different identity. So there's, this is a work in progress.
And so like, this is a solution, but there are like other potential solutions also. So what I would like to, achieve also is to actually have, the discussion actually, on the working group list. It's a very new draft. We need to give people the opportunity to dig through it.
It's 3 days old. What do you mean?
It's new. So, and that's sort of like we need to assess, what are the exact, requirements from a protocol specific, kind of perspective, and see how, which solution maps the best into that. And I think it would be a very interesting discussion topic for the next interim to assess, what would be like, a good path forward. I don't think we should wait too long for these kind of things. It is actually, at this point in time, out of charter also, and I would like to finish our milestone deliverables as a first, topic. But I do see this as a very interesting, side track we actually can work upon, but it should not be, influencing our outcome deliverables in about a year from now. Jeff.
Just answer on North Network. So if you feel that applicability is wider than BGP's PF, you're welcome to come to routing and present.
The acoustics up here suck.
Come to routing and present if you feel that it's wider than just BGP.
So
Working
Randy,
group, routing working group.
I'll repeat it, Randy. So I think what he's suggesting is that if it has wider applicability, he's suggesting you go to the routing working group to also have it discussed there.
I haven't got religion.
I hope I channeled you correctly there, Jeff.
Thanks.
Cool, thank you.
Okay, so there's a few things we'd want to go over since we've exhausted the drafts we're going to discuss today. But before we do that, if there's any last minute comments before we then work towards a conclusion for this session? Guess not. Okay. So we have a couple of drafts that there's some initial review we had today. Just want to recap that and get a sense of the room on a couple of points here. So the first draft we'd like to discuss was the Lsvr BGP SPF document. That was the document discussed by Keir earlier on in the session. Coming out of that document review, it looked like we were still looking for some additional reviewers, if possible, within this group. We had a number of folks, close to about 20, that showed hands that they had read the document. What we were looking for was list discussion, and whether that be supportive or corrections to the document, other ideas, whether it looks like positive or negative, we want that discussion on the list. And so that we can figure out, is this document in a form that we can then proceed to adoption of the working group, or does the document require some adjustments before we can do that, or take any other particular suggestions we might get on the list? Would that be fair to, as an encapsulation, Gunter, from what we heard today? Yeah. I don't think we need a show of hands for that. I think we had a show of hands for the number read. Okay, so that's what we would like to see in the list. And if that can be done, I know it's asking a lot of folks are busy coming out of this week, to have that done within the next couple of weeks, that'd be very helpful for us so that we can work towards what we would do in an interim meeting to help progress the work of the timelines we do have. The second document that we wanted discussed in the list, and we have a commitment, pseudo commitment AC, for the 14th of April, I believe you've signed in blood for, that we would, once that's produced, I was joking, by the way, once that's produced, we would like to get a list discussion on that particular document. There was quite a bit of discussion here today. It would be good to then get that document read and discussed at length within the mailing list, so that we can look also to get a sense of whether we can adopt that as a working group document within the team. And then the third document was with the control plane over Ethernet, the one we just concluded with. Sounds like the consensus was potentially some additional review at the routing working group, since this might have wider applicability than just within this particular working group. And what I got from my co-chair was that we also want to ensure that we make progression on our current charter milestones. We wouldn't necessarily want to be held up by this per se. Oh, there's a comment.
Jeff, so for the last one, the material Randy presented, the state that the Lsvr stuff needs is well covered in the document. So I think one way or the other, the working group needs something like that. But the protocols that carries it, I think, is the open question.
That's fair.
Keir Patel, one of the reasons why we presented it here is because aside from what we do with Lsvr, what actually would be really helpful is some form of a neighbor discovery. Now, we have had solutions that run over LLDP and few other ways to incorporate this. It would be nice, and I think it would be it'd be super cool if there is a generic mechanism that has been devised to do the neighbor discovery, kind of like how we have standardized BFD. And I think to that point, this solution was presented. Considering it has an applicability to the work we do here, it would be my opinion as a working group member to strongly suggest that we incorporate into a charter like this, or at least track to say that there has to be some neighbor discovery solution that we should be adopting or considering to, whether it belongs in this working group or whether it belongs in RTG, is something we can debate and discuss.
With regards to data modeling work, which is in your charter, we are updating routing policy model, which is going to be presented in routing tomorrow. So whoever is going to work on young, please take a look at routing policy because eventually you'll need to have redistribution and stuff.
Also, do the blue sheets back there, has everyone had an opportunity to sign the blue sheets?
Where are the blue sheets?
Yeah, that's the next question. Where are the blue sheets? Anybody see a blue sheet close to them? Okay, one there. Should be one more.
Yep.
Oh, okay, they're both back there. Okay, I'll grab that. Well, guess.
That's it. I think you all won back about like 30 minutes.
Yeah.